Let's see the question. Let x be a vector in the plane containing vectors. A is 2i minus j plus k and b is I plus 2j minus k. If the vector x is perpendicular to 3i plus 2j minus k and its projection on a bar is 17 times root 6 by 2, then the value of determinant of x square is what? Let's see how to find the vector x. One thing given, the given vectors are a and b, isn't it? So these are the vectors. And also they said x lies in the plane containing a and b. So in the plane x is there and it contains a and b. So if x is containing a and b, you can express this as a linear combination of two vectors. So that is x equal to lambda a plus mu b. Now we know a and b, isn't it? So let's write a and b here. So x bar equal to lambda times, what is a? 2i minus j plus k plus mu into, what is b? I plus 2j minus k. We have a I and here we have a I. So if we take I as a common, then we are going to left 2 lambda plus mu. If we take j as common, then we are going to left minus lambda plus 2 mu. If we take k as common, then we are going to get lambda minus mu. So this is the x vector. Now let's read the question. So what they said. So according to this information, we written x as a linear combination of two vectors. So now we got the x vector in terms of a lambda and mu. Now remaining what they said if vector x is perpendicular to the 3i plus 2j minus k. So if the x vector is perpendicular to this vector, that means any vector perpendicular to the another vector, that we can write it as in a dot product, isn't it? So that's why here x is perpendicular to the 3i plus 2j minus k. So we can write this as x dot 3i plus 2j minus k, that is equal to 0. We know the x vector, which is I times 2 lambda plus mu plus j times minus lambda plus 2 mu plus k times lambda minus mu. So now we have to do this is the x vector dot. Now what we have? 3i plus 2j minus k, that is equal to 0. So now I have to do dot in between these two. When you are doing dot, what we know? I times I is nothing but 1. J times j is 1. K times k is 1. So when you do with I times j, that is 0. So that means if we multiply with the same product, we are getting 1. If you multiply with the different vector, then we are going to get 0. So apply this property here, then we are going to get, so here we have a 3 times 2 lambda plus mu, which is 6 lambda plus 3 mu. Another one, j times j, that means 2 times minus lambda plus 2 mu, which is minus 2 lambda plus 4 mu. Now we have k times k. What we have here? Minus 1 times lambda minus mu, which gives minus lambda plus mu, that is equal to 0. Here 6 lambda minus 2 lambda, which is 4 lambda. 4 lambda minus lambda, which gives 3 lambda. So here we have 3 lambda, and what we have? 3 mu plus 4 mu, which is 7 mu, and plus mu, which gives 8 mu. So 3 lambda plus 8 mu, that is equal to 0. Let's consider this as a equation 1. So using these first two line sentences, we written as a x as a linear combination of a and b vectors. So after that, using this sentence, x is perpendicular to this vector, so we written as a dot product, and we found one equation. Now what they given? They given projection on a bar, which is 17 root 6 over 2. So the x is projection on a bar. So now use this sentence. So x is projection on a bar. That means, what is the formula for this? X dot a, determinant of a vector. So what is this value? This value is 17 root 6 over 2. And we know a vector, which is 2i minus j plus k. Here we can find the determinant of a, which is square root of 2 square, which is 4, plus minus 1 square, which is 1, plus 1 square, which is 1. So we are going to get root 6 here. So determinant of a, the value is root 6. If we get x vector dot a vector, that is equal to 17 times root 6 by 2. Here root 6 times root 6 is nothing but only 6. When you divide by 2, we are going to get 51. So x dot a, the value is 51. We know x vector, which is I times 2 lambda plus mu, j times minus lambda plus 2 mu plus k times lambda minus mu. And here we have to use a vector. So this is the x vector dot What is A vector? A vector is 2i minus j plus k. Here you have to multiply I times I. So which is 1. So now I have to 2 lambda plus mu times 2, which is 4 lambda plus 2 mu. And here minus lambda plus 2 mu times minus 1, which gives plus lambda minus 2 mu. And here we have lambda minus mu times 1. So that is lambda plus mu. So what is the value of that? The value is 51. So you have to write that is equal to 51. Here 4 lambda plus lambda plus lambda, total 6 lambda. 2 mu minus 2 mu gets cancelled, so we left only minus mu. That is equal to 51. Consider this as the equation 2. So in equation 1 what we have? 3 lambda plus 8 mu equal to 0. In the second equation what we got? 6 lambda minus mu equal to 51. When you multiply by 2 to the equation 1, we are going to get 6 lambda plus 16 mu, that is equal to 0. If you do minus on both sides, then we are going to get minus 17 mu, that is equal to 51. So mu value is minus 3. Substitute this in equation 2. So what is equation 2? 6 lambda minus mu, that is equal to 51. So what is mu value? Minus 3. So minus of minus 3, which is plus 3, that is equal to 51. Then 6 lambda equal to 51 minus 3, which gives 48. So the lambda value is 8. Now we know lambda and mu values. So x we can write it as a linear combination of two vectors. So what is the lambda value? 8. A vector 2i minus j plus k. This is A vector plus mu. What is a mu? Minus 3 times B vector. What is B vector? B vector is I bar plus 2j minus k. 16i minus 8j plus 8k plus minus 3i minus 6j plus 3k. 16 minus 3, which gives 13 I bar. Then minus 8 minus 6, which gives minus 14j bar plus 8 plus 3, which gives 11k bar. So this is the x vector, and our goal is to find determinant of x whole raised to the power of 2. So let's first find out the determinant of x. What is determinant of x? Square root of 13 square plus minus 14 square plus 11 square. So what is 13 square? 169. What is 14 square? 196. Plus what is 11 square? 121. So after this is square root of. After adding we are going to get 486. This is square root of, but we need to find the determinant of x whole raised to the power of 2. So if we do square on both sides, we are going to get determinant of x square as 486. This is the value of this. If you like this content, please like, share, subscribe to the channel. Thank you for watching.